Hi, and welcome to 7.2. And in this video, I'm going to be talking to you about how you can write the formulas for covalent compounds. The difference between ionic and covalent compounds is that covalent compounds are always made of that's right, you guessed it, nonmetal and a nonmetal. They're made of two nonmetals. So, whoa. Okay, let me get my pen working. Okay, two nonmetals. Notice there's 0 metals in this picture, only nonmetals. So if you ever see a metal, you know it's not covalent. It's ionic. So for nonmetals, they form covalent bonds, and we're going to talk about how to write their formulas. Before we jump into it, I want you to write this on your page somewhere. These are called prefixes, and these prefixes will tell us the number of atoms present in a formula. So anytime you see the word mono or the prefix mono, you're going to think of the number 1. Anytime you see the prefix di, you'll think of the number 2. Tri means 3, tetra means 4, penta means 5, hexa means 6, hepta means 7. The way I remember hexa and 6 is that they both have an X in them. So hexa is 6. Octa is 8, nona is 10, and nona is 10, and deca life. Nona is 9 and deca is 10. So now that you've written that down, let us move right along to our paper. In this video, I'm going to be giving you the names of covalent compounds. How do I know this is covalent? Well, sulfur, I know, stands for, the symbol for sulfur is S. And then I know that this is talking about oxygen. I know it looks funny because it says trioxide and the ending is changed, but oxide stands for oxygen. So I know there's an S and I know there's an O. Okay, so I know it's covalent because S and O are both nonmetals. So how do I write down the formula? Well, I already know what to write down first, and that's S, because sulfur is written first. I write it out first. Now, since there's nothing in front of sulfur, it's just the word sulfur, then I know I only have 1 atom of sulfur. If I was to have 2 atoms of sulfur, then I would see a prefix in front of the word sulfur, like disulfur or trisulfur. But since there's no prefix means I only have 1 atom. Okay, so trioxide means that I have oxygen right next, but the tri part stands for the number 3. Sorry, this is super messy. So tri stands for 3, so that means I'm going to put a little 3 next to the O, meaning that I have 3 oxygens. Okay, let's do another example. Carbon monoxide, the first thing we do is we write the symbols. We have carbon and we have oxygen, so I write C and O. Okay. There's no prefix here, which means I only have 1 carbon, right? So I don't put any number right here. I just leave this part blank to indicate that I have 1 carbon. Mono means 1. So anytime you see the word mono, you know that you just have 1 oxygen. So I'm not going to put anything here or anything here to represent that I have 1 for each atom. Okay, now let's look at carbon dioxide. Again, we have carbon and we have oxygen, so I write CO. There's no prefix in front of carbon, so I don't put a number next to carbon because that represents 1. But the di in front of the oxide means that I have 2 oxygens, so I'm going to put a little 2 here to represent that there are 2 oxygens for every 1 carbon. Let's move on to the next example, boron trifluoride. So there's no prefix, so I just write B. Tri means 3, and fluoride means fluorine. So the tri means that there's 3 fluorines. So I write BF with a little subscript 3. Okay, now let's move on to tetraphosphorus hexasulfide. I see that my 2 elements are phosphorus and sulfur. So I write P and S. The tetra in front of phosphorus stands for 4 phosphorus atoms. So I write a little 4 here. The hexa in front of sulfur stands for 6. Remember, 6 has an X in it, and so does hexa. So I write P4S6. My last one is xenon difluoride. Xenon, the element is Xe, and then fluoride stands for fluorine. And there's no prefix in front of xenon, so I leave it blank. The di in front of fluoride stands for 2. So I have 2 fluorines. And that is it for 7.2.